Okay, let's take a look at another stress strain question involving a piston, because these ones seem to be causing some problems. All right, this one, if the safety factor of a piston under a working load of 800 kilonewtons is 7.85, what is the diameter of the piston if the ultimate strength of the material is 800 megapascals? Well, the first thing I'm thinking about here in the question is that they're talking about safety factor. So I'm always thinking about that safety factor formula. So my safety factor is going to be equal to my ultimate, and this could be either in stress, load, strength. In this case, we'll talk about strength in the material it's mentioned. And then we'll divide that by the allowable strength. Okay, so that's my first formula I'm thinking about. Now, with regards to that then, the next thing I want to do is rearrange this formula to find the thing that I don't know. Now, in the question, you can see that they've given me the safety factor, that's 7.85, and I've also got the ultimate strength of the material, that's 800 megapascals. So the one thing I don't know in my equation over here is the allowable strength. If I rearrange it then, I get my allowable strength will be equal to my ultimate strength and then divide that by my safety factor. So pushing the numbers in, the ultimate strength was given in the question as 800 megapascals and my safety factor was given as 7.85. So if we divide 800 by the 7.85, let's just move this over here, we get 101.911 megapascals. So that's the allowable strength or the allowable stress on my actual piston and piston rod. So now that I've got that, the next thing I'm thinking about is I have to get over to find this diameter of the piston. Well, I can get diameter from the area. So the next thing I'm thinking about then is I need a formula that involves area and stress that I just worked out. So that particular formula then from your academic supplements is that stress is equal to our load divided by my area. If I now rearrange this formula to find the area, my area becomes the load divided by the stress. So now I can put my numbers in. The load was given in the question, and you can see it on my diagram. That was 800 kilonewtons. Let's pick up 10 to the power of 3 because it's kilo. And then we can divide this by our stress. The stress is what we just worked out over here of this 101.911 megapascals. So let's put that in. 101.911 times 10 to the power of 6 because it's mega. Now we have to keep the units clear here because we're working in kilo on the top and mega in the bottom. If you divide that by that, we'll end up getting our area, which is going to be 7.85 times 10 to the minus 3 meters squared. And once again, don't worry too much about this number. I'm just writing down what the calculator said. Now, once we've got the area, I can now think about the area formula for this piston. And the area, as it's a circle, is going to be pi d squared over 4. I now need to rearrange this to find the diameter. Well, the first thing I would do here with regards to the transposition is I would bring that 4 up. So that's now going to give me 4a equals pi d squared. The next thing I'd want to do is take the pi away from the d, and it's a times over on the right hand side, so if you move it to the left it becomes divide. So now my formula is looking 4a over pi is equal to d squared. 1 second, that's a funny looking d. Okay, so now that we've got that, I now need to remove the squared term over to that side. And the opposite of a squared is a square root. So my final formula here, if I rearrange it in sort of the classical way, it's going to be diameter is equal to 4 divided by a all over pi. And now to get rid of that square, we take a square root. We can now go ahead and shove some numbers into this formula. So 4 multiplied by my area that we found up here, and this number here is our 7.85 times 10 to the minus 3. let's divide all that by pi and then take the square root of the entire thing. If you push all of that through your calculator and then press your engineering button to make it a little bit more palatable with regards to a number, we can express it as 99.975 millimeters, where basically your calculator should be telling you that it is in 10 to the minus 3, which is milli, of course. Now, that number is very, very close to 100, so we could possibly expect to see on an exam, for example, that they would have rounded this off to possibly 10 centimeters. Hopefully you recall that there are 10 millimeters in every centimeter, so therefore 100 millimeters is 10 centimeters or 0.1 meters. Good little question, this one. Hopefully this one helped you out, and I'll see you again real soon for another one.